Alrighty, 3-5. Alright, start. Short stack. Oh, maybe it's about poker. Let's see. Oops. XO with love. Alright. Here we go. Oh, it's not short stack. Never mind. It's sort stack. Okay. God dang it! That's all right. Rename. Yes, but then I want to change short stack to sort stack. Okay, so this one. All right, there we go. Yeah. All right, sort stack. Write a program to sort a stack such that the smallest items are on the top. You can use an additional temporary stack, but you may not copy the elements into other data structures such as arrays. The stack supports the following operations: push, pop, peek, and is empty. So it's okay. Actually, I have a question already. Are they saying give me a program? I mean, because stacks already support those four operations. So if you have a stack implementation, you don't need to do anything. But then is the question: give me a function that can take a stack and return a sorted stack, or is the function give me a data structure where the items will always be sorted, or give me a stack where the elements in the stack are always sorted. Um, I feel like the fact that they mentioned the stack supports the following operations: push, pop, peek, and is empty, kind of means that they expect the stack to always be sorted. I'm also going to read into the you may not copy the elements into any other data structure, such as an array, being indicative that you should not just use, like, copy them into an array, sort them, then put them in the stack, you know? Um, Although there's. Mm, on the other hand, they go into the trouble of mentioning this temporary stack thing, but maybe that's just because they're saying you can use stacks and you can use stacks, but you can't use any other data structure other than stacks. So I think that I'm reading this as saying you want a stack whose elements are always sorted, which isn't really a stack, is it? Maybe it's not what they want. Jeez, that's confused. Okay. Write a program to sort a stack such that the smallest items are on the top. Huh. Yeah, I'm not clear whether they want a program that will sort a stack and return a new stack in sorted order, or whether they want a stack whose values are in sorted order. I so let's just I think I'm not clear, but I kind of think they're just saying give me another function that lets me sort the stack. And I guess if we write a function that can sort a stack, well, of course, I mean, no, it does matter, right? I mean, if we write a function that can sort a stack, then we can also give you a stack that is always in sorted order. Um, yeah, there's a lot of questions I have about this. I feel like the fact that they mentioned the temporary stack thing. I mean, if I have a temporary stack, I mean, you give me a stack and I have a temporary stack, then I can just be copying your nodes. Actually, yeah, I don't think you can do it. I mean, they say you can only use an additional temporary stack. So if I can only use one temporary stack, can I actually sort another stack? Yeah, I mean, you can, right? Like, let's say you had 132, right, in your stack. You want it to be sorted. You take the one off into the temporary. You now have 3 2. No, actually, a single temporary stack doesn't really help you because all you can do is pop off the top of the temporary stack. You have no way to flip elements unless you're also capable of grabbing the element and putting it somewhere else, and then looking at the top of both of those stacks and saying, okay, let's put things back the way they were. Which is, I guess, fundamentally like kind of the equivalent of bubble sort with stacks. Um, so if you can hold a third element, which is just like I'm holding this element and asking myself questions, so you can hold one element and you can have two stacks, right? The stack that you came from and the stack that your temporary stack, right? Then yeah, you can end up sorting things that way. Um, but I don't think there's any. I think it would be better to just have a sorted stack. Um, so how would you do this realistically? Well, realistically, I think I do. Realistically, I think I would just push. Nope. Pop. So we have a stack implementation now. Let's just see if that is a valid stack implementation. Chapter 3, 5. Actually, I know the bottom ones had a few tests. Tests. Huh, that's weird. 46. Test. Where's where did I change this from? Tests. Namespace. Did this work? Chapter 3, problem 3. Run test. I think maybe we saved the wrong one incorrectly too. Gosh darn it. Tell me it's not so. Whoa. Wait a minute. I swear we ran this. Was I running the wrong... Or did I just save the wrong data? No. I gotta fix this issue with I can't do commit amends, but well, for now that's what it is. So anyway, t/run test is what should be running there. And all right, so I think this is a fail 3. Okay. Yeah. Okay. So we're failing on the test the peak, and test the underlying. Let's start with the test the underlying. My pop 1 2 3. Yeah, should be in instead of returning 2 3, it should be 1 2. Because now we're back to being a stack and not a weird queue. 1 2 3 4 5. Take 5. Oh, that's a weird one. 1, 1, 1, 1, 1. Okay, yeah, our peak is actually not the first anymore. Now it is actually the peak. Okay. So now everything's just reversed because I think that makes sense. Okay. So back to being a stack from the previous problem where we sort of made a stack into a queue. Well, no, that was definitely wrong. Because I modified the wrong one, didn't I? Okay, so we got a stack now, I believe. So now we just need a stack that's in order, you know? Which isn't really a stack, but... yeah, I'm just not clear. So we have here a stack that supports the following operations. Pop, peak, is empty, and push, right? What we don't have is a sorted stack. Now, we can make it a sorted stack by simply saying, you know, conj onto vs, and then vec conj on vs v v. Oops. Vec of sort, that's what I meant to say. Oh, so this smallest is on the top. Okay. I forgot how to write a comparator. I feel like maybe I should just write like -1 times this. Let's see what happens. So now everything is always 1, 2, 3. I think, because you can't put them in reverse order. Oops, wrong way. So the bottom of the stack should be... Yeah, I prefer to just look at the data structure. So yeah, this is the data structure. It's harder to think about in terms of the mapping, but no matter what you do, you're going to end up with 1, 2, 3, 4, 5, right? Doesn't matter whether it's ascending or descending or what. And so that has to be true here too, whatever's going on. Or maybe it's the opposite, because you're taking the peak. So you started at 5. Maybe this one has to be 5, 4, 3, 2, 1 for all of them, because you're always sorting. Let's see. Nope, just made it worse. Alright, focus on one thing at a time. Let's comment out some of these that are failing. Alright, so we're failing all 3 out of 5 of them. Yeah. So 1, 2, 3 on my push. 1, 2, 3 should have 1, 2, 3, but instead we had 3, 2, 1. Oh, okay. Maybe we're actually backwards, because that isn't the order. Wait, no, that is the right order actually. Such that the smallest items are on the top. Oh, okay, yeah. It's my tests that are backwards. So everything should be the other order. 3, 2, 1. This guy shouldn't be 1, 2, 3. He should be 3, 2. This guy shouldn't be 1, 2, 3, 4, 5. I think he should be 5, 4, 3, 2, 1. Let's see. And this guy shouldn't be 1, 2, 3, 4, 5. It should be 5, 4, 3, 2, 1. Okay, so we still got one error. 3, 2. It's not equal to 1, 2. Well, I declare. Yeah. My pop on 1, 2, 3. Okay, yeah, it doesn't matter what order you specify them in. This is my pop on 1, 2, 3. Doesn't matter what order you specify them. Effectively, they're always going to be in sorted order. Right? So it's going to end up 3, 2, 1. And if you pop 1... Oh, wait, but this is... interesting. Yeah, this is not an order that could actually occur. It would have to be 3, 2, 1. And similarly, this one would have to be like 2, 1, right? Okay. Because our stack is always ordered, right? Let's see what we got here. Okay, 5, 4, 3, 2, 1. So what are we saying? We're trying to say that you should be, that's the right order in terms of the output. 2, 1, 1, okay, but it's not actually working. And so all we're doing, my push, doesn't matter what order we push them in, really. They're going to end up being the same thing. But that's not seemingly true. 5, 4, 3, 2, 1 is not equal to 1, 2, 3, 4, 5. Yeah, this is not the final result. This is the... So I think we actually do want it the other way. Am I just correcting things, or... I'm fundamentally saying when you have the full stack, it should be the first thing you should peek is 1, and the second thing you should peek is 2, then 3, then 4, then 5. It doesn't matter whether it's ascending or descending in terms of what we passed in. In fact, these two things are identical at this point. And then 1, 1, 1 is just, of course, 1, 1, 1. Let's see what else we got. Okay, so I think that's it technically for does it satisfy the constraint? And yes, it does. I have not converted it into any other data structure. It is still a vector, right? It's still a stack, but I have sorted it, which probably meant making an intermediate vector or something. I don't know, stack, and okay, but that's probably not what they mean, right? So this is the obvious solution. What they probably meant is something that is going to use a second stack to sort the source stack. So basically, when I push, I can push anything that is less than V onto my second stack and then pop it back onto the first stack. And I only need to start from the head, so to speak, because I know the things at the head are the minimum, right? So because I have a vector here, right, I actually can take the rseek of this VS, right, which is so that's the reverse sequence of the VS, and I can actually do that in constant time, right? And I can just keep taking this. Oh, let's see how far I can go with this. I can keep taking this while take while something is less than something. Take while V is less than this, is that right? Yeah, well, V is less than this, then take it. Well, no, while this is less than V, then take it off the end, right? And, okay, so we're going to have a sequence of things that are smaller VS's, right? And they're in their smallest to largest order, oddly enough. Okay. What then we can do is we can just grab that and we can say, okay, let me take my well, I can get a size, a count on that, right? C is the count of smaller VS, which is also another linear cost operation for a sequence. right? This is a finite sequence. Well, it's not the whole n at least, right? Because it's only going to do it while it's true. But we know that that should only be the thing. The things that are smaller should be at the end of the stack, right? Or at the head, I guess, of the stack. But C is the count, and so I should just be able to say subvec of potentially just subvec of 0, no, well, subvec of vs of 0 to, oh, this is where we get, I hate, 0 to the count of vs minus c. This sucks. There's got to be a cleverer way to do that. How about, no, I can't just use but last or whatever the thing was that let us pull off the end, because that, what was it? It was like take last, I think, yeah. I mean, this is kind of what we want to do. We don't just take the last, but if we do that, oh, you know what? That actually isn't too bad. Oh, okay. Let's think of what we got. We got all the items on the stack that are greater than me, right? Or that are less than my value. And so now, and we have them in, oddly enough, reversed order, right? And so now, let's do that. Okay. Yeah, we might as well make it into a little vector. And so that is effectively our second stack, right? Now we have, I think reverse returns a vector, but I don't even know what it's going to say. Actually returns a seek. Not lazy, though. That makes sense, but I wonder why it doesn't just return a vector if it's not going to be lazy about it. Well, whatever. Strange. Alright. Reverse. Smaller VS. I guess let's just make it into a vector, just to make it similar. No, we don't really need to. So now, so anyway, we starting from the back, right? We took while the items, and the back is the end of the back is the end of the stack, right? Or the head of the stack, right? We took from the head going towards the root of the stack all the items that were less than v, and then we reversed them, right? Because we were already reversed, and so we want to unreverse that to get basically the things that need to be put back onto the stack. Or maybe we don't. We'll think about that later. But we do know that we have the size of all the number of items that are smaller than VS, right? And we also have the items. So I hate to do index stuff at all, you know? I don't want this thing in here, and I don't want to be doing index stuff, but I mean, I can take the count of VS, right? And that could be like a number. Then I can subtract from it C, right? Let's just do C. And then I can add 1 or subtract 1 or whatever, you know? So if I take the total count, let's say the last 2 items were smaller than me, and there's vectors like 5. I have 5 minus 2 is 3, right? And so it's going to try to go from index position 0 to index position 3 non-inclusive. So it's going to take 3 elements, 0, 1, and 2. And it's going to 3 and 4 are basically in here. So yeah, if I basically have 1, 2, 3, 5, 6, right? And I try to insert into this thing the value 4, it's going to then parse it as 1, 2, 3. I got a second vector that is my temporary one, stack, whatever, of I believe it's currently 6 and 5, right? And then I also have still this 4, right? And I'm going to go into, which I want it to run, I mean, ultimately I want it to return as 1, 2, 3. Oh, this is backwards, isn't it? 6, 5, 3, 2, 1. All right. And so we then have 6, 5, 3, and then we have a second vector of 2, 1. And we have 4. So we ultimately want to return a 6, 5, 4, 3, 2, 1. Right, that's the ultimate result. So I think we're kind of like if we need to get the subvector to this point, right? 6, 5, 3, which I think is this math. The count of VS minus the C, the number of items you pulled out, which is 2. So 5 minus 2 is 3. And then I think you need to, I guess you don't need to do anything really, I think. 5 minus 2 is 3, and so you're going from you're going to get the elements at position 0, 1, 2, which is this, right? You still have element position 3 and 4 here from doing this in sort of reversed order, which is a bit odd, but whatever. And then is that what you have? Do you have 2 and 1 or 1 and 2? I got to think about it. You took from the reverse. So actually, I think you have 1 and 2. Yeah. Okay. So anyway, then you're like, okay, cool. I've subvect this, and then I'm going to conj onto this. I'm going to conj the value I have, which is v, and then I'm going to conj the smaller VS's on top of that, which is smaller VS. But it's in the wrong order, so I guess reverse it. I don't know, you know. So instead of this being 1, 2, it'll be 2, 1. So now we go 6, 5, 4, 3, 2, 1. Okay. So we had a passing thing previously. Let's see how much I screwed up. A lot, it looks like. Closure length precision bubble cannot be cast to a line number. Line 18, column 46. Well, unsurprisingly, it's probably right in here. Alright. I got VS. I'm going to rseek on it. Okay, that cannot be the issue. Then I'm going to take while on the thing I've reverse seeked. Taking while U are less than V. And you're telling me something about empty list cannot be converted to Java lang number. Now, why do you have the empty list? Oh, but I read through the supply. Right. Oh, well, there you go. That's weird. It felt like the error was coming from up there, but it feels like it's actually just coming. Oh, well, yes, because it's a lazy sequence. No, actually, it's not really a lazy sequence because we're reversing it, right? So why are we seeing the error reported as up in there when it seems to be line 18, column 46? Okay. It seems like you're saying the error is up here, but it's not. It's clearly right here. And you might ask, how did that work? Well, it actually turns out conj is actually variadic, right? It can take any number of things you're going to conj onto the original collection. And so I'm putting one thing in there, and then I'm putting a sequence of things at the end, which apply and expands out the last of its arguments to convert a sequence into a sort of splatted or spliced series of things. So that's the non kind of obvious way, which is this is I think a lot better, honestly. Um, but I guess it ultimately kind of no, this is better, right? It's simpler to just reason. Well, every time they put something into the thing, it resorts itself, right? I guess no. I mean, this is in log n, right? While this one is just n. Worst case scenario. And it's going to realistically be a lot less than n because most of the time it probably doesn't have to go through everything to insert something, you know? But anyway, let's read the hints, see what we missed. All right, first hint is number 15. Number 15. All right. One way of sorting an array is to iterate through the array and insert each element into a new array in sorted order. Can you do this with a stack? I think so. Okay. Number 32 is imagine your secondary stack is sorted. Can you insert elements into it in sorted order? You might need some extra storage. What could you use for extra storage? Well, I thought we said we weren't allowed to use extra storage in any other data structure. Guess, do you just mean a symbol that I can hang a variable or value on? I don't know. Number 43. Keep the secondary stack in sorted order with the biggest element on the top. Use the primary stack for additional storage. Huh? I feel like we're talking about a different problem practically. Keep the secondary stack in sorted order with the biggest element on the top. Use this primary stack for additional storage. I don't know what the hell they're talking about, honestly. That didn't really help that much. This seems to kind of work. Well, whatever. I need to finish stuff up because I'm hungry and tired and that all sorts of other. Alt W, okay. Let's commit. Oop. Let's call it sort stack. Okay.